Good. Yeah.
All right, guys, let's take a look at this together here. I'm hoping the first several went pretty well. Let's see how quickly I can add. Is that 92? 11. Good job, Jeff. Is that 146?
Yeah.
Yeah.
And then,
50.
oh, you can't see, 50. So 176 total. You can check this way too. Okay. So don't add these people to this people. We already talked about that, right? They're the same people. Okay. All right, this should have been nice and easy. And again, every time I ask you a new question, everything resets, right? They don't depend on each other. So it's probably that they attend Grossmont. What's the fraction?
176 over 126 over 176.
There it is. And what do you guys get for the decimal?
Point.
7159.
7159. Yeah.
Crowdsourcing these. So, okay. And now part B is a brand new question about the same group of people. Nothing's happened to them. Probability that I pick a business major, of course. What's that going to be?
92 out of 100.
Yeah, I got 92 chances to get a business major out of 176 total people I could get.
0.5227.
5227. Sounds good to me. All right. Coolness. So part A and B are very straightforward. I always get somebody to say 55 for Grossmont, but of course that would be if I said Grossmont and business major, right? So I just gotta look at the end of the row. So part C, computer science major or attends Grossmont. I don't have a meter sticking there, it's too bad. So, computer science major or attends Grossmont. The way I would do this problem, Grossmont is 126. How many computer science people have I not counted yet?
11.
11. So that would make 137. Now what's the other kind of more technical way to do it? You can take all the Grossmont people, add in all the computer science people, but then you have to subtract how many?
62.
Because that's how many, oh, you double counted.
Couldn't you just take all the Grossmont students, and since you already counted the computer science in that, just add the rest?
That's what we did first. So if I take all the Grossmont 126, how many computer science have I not counted yet? 11. Yeah, good. I like it. So either way you do it, man, this is so far away. You get, now I forgot what the hell I was doing. 137, it's all right. Out of 176. And then, what's that?
0.77.
7784. Now again, the formula would work. It would just actually be more work than you have to do. And part D is where people really get confused. Dear God, don't even look at the formulas if I give you everything to count. Part D is easy as shit. How many students are math majors and Cuyamaca students? There's only 2 that do both, right? Remember the mean bouncer was and? He lets the fewest people in the bar. Didn't we talk about the bouncers? Or the door people, whatever that you want to call them? All right, so 2 out of what? Yeah, because I don't know shit about them. They could still be anybody. And then what's that?
0.0114.
0114? Okay, so you guys got it. Okay. So part E is the first time the bottom is not 176. Grossmont student given computer science. So what's my universe? How many people are in my group now that I know I'm talking about?
73.
Yeah, so I've got 73. So you can just do this. Out of those 73, how many are Grossmont students?
62.
62. Because now I just throw all these other people out. I know it can't be them. So it'll be 62 out of 73.
0.8493.
8493? Sounds about right. 849.
3.
Oh, yeah.
Okay. Again, I'm proud. I'm not even doing it myself, so you guys got to self-correct. All right. Part F, I didn't really talk about directly, but I really want this to make all the freaking sense in the world. To discover if they are independent, I have to see how they interact. Does that make any sense? Yes, right? The only probability that actually looks at how they interact is a given. That's the only probability that thinks about, well, if one happens, what happens to the other one? So here, look. The probability that a Grossmont student, given that I know they're a computer science major, is this. But what's the probability they're a Grossmont student if I don't have a clue if they're a computer science major or not? This, yes? So if I know that they're a computer science major, does the probability they're a Grossmont student change? It was this. That's what it is for a Grossmont student. But now the probability they're a Grossmont student, given their computer science major, does that change? Definitely. It goes up quite a bit, yes? The probability goes up. So therefore, they are dependent. Wouldn't you say the probability they're a Grossmont student depends on if I know this or not? Doesn't it? Because it changes if I know that. So when would they be independent if the given was the same number? Then they wouldn't give a shit about each other. Given this happened, this one didn't give a shit because it stayed the same number. Isn't that what dependent, independent should mean? Yeah. If you're independent from somebody else and they do something stupid, do you care? No, I don't give a shit what you do, right? You with me? If you're a little kid with your mom and she does something stupid, you're gonna care. That could affect you because you're dependent on her. All right. Maybe. So how do you officially answer this question? You officially answer this question with very few words. The minute you're writing a lot of words, you are wrong. Trust me. So how do I know that these are independent or dependent? Because the probability of Grossmont students does not equal the probability of Grossmont given computer science. 0.7159 does not equal 0.8493, so they are dependent. That is the only way to answer a question about independence. It is a mathematical idea. Don't start a little paragraph. Well, you could be a computer science major. It doesn't really matter where you're going to school because you could do this. No, you're wrong already. It's got to be a math idea. Okay. I really want that to make sense. The given is the only probability that looks at interaction between two things. So it is the only thing that's going to help me answer this question. All right. Okay, all right. Number 2. Okay. This is probably where a lot of them should be, but if we have 7 Democrats, 12 Republicans, 2 independents, and how many political parties are there? You know?
We talked about it. There was like
Oh, we did. All right,
300 and
there's a lot.
something.
Well, there was 1,028 candidates for president in the last election, and there's 53 parties that I know of. So, yeah, there's actually more than that now. I used to only know 53. Anyway, all right. Sorry, but we're just looking at the big 3 here, right? This is the big 3. We pick one person. What's probably their Democrat? What's the fraction?
24. Oh wait.
7.
Pick one person. Yeah, it'd be 7 Democrats, so we get 7 chances out of 21. And that's a nice one. That's 3, right? What's that? What's probably holy shit, Jeff? What is the probability that I pick a Republican?
12 out of 20.
Peter Piper picked a Republicans.
12 out of 21.
Yeah, I'm sorry. I got to catch up here. It's 12 out of 21. It's 4 out of 7, which is 0.5714.
Yeah.
Now that one, I just have my divided by 7 sort of memorized. Because that's what math people do. We're exciting people. Just call it. If we select 2 people in random, now it depends. Now I gotta be careful. With replacement, okay. And we got 2 people, so I know I'm gonna make 2 spots. If I was selecting, I don't know, 4 people, like maybe the one about the chocolate milk, which is a true story. But if you go to that link, it actually talks about how the survey, you're not really sure how many of them really think that. Anyway, it still is an interesting headline. And the really sad thing about this is, I'm almost certain when you read this, you weren't that surprised. Yeah, that's what's really sad. Okay, sorry. So we do this with replacement. I've got 2 people I'm digging. I'm having my 14th puberty. What's the probability the first person is an independent?
2 out of 21.
Yeah, you got a 2 out of 21 chance. And then of course, now they're out of the haunted house. Like, oh, thank you, and then we shove them back in. Right, and then we pick. Let's probably get a Republican after that.
12 out of 21.
12 out of 21. Is everybody with that? Yes. This is with replacement. Everything resets. Shove the poor person back in there. And whatever the hell that is.
0.0544.
Sounds right. 0.54. And then 2 Democrats. Now, do you notice the word "and" doesn't show up in Part D? And the word "and" is evil with the English language, especially, well, the English language is evil. Anybody who's learned the English language second after a different language can totally understand what it's. It's a very evil language. And is hidden in there. 2 Democrats means Democrat and then another Democrat. So there's an "and" in there. So I'm going to make 2 spaces again. First one's a Democrat would be
7 out of 20.
7 out of 21. Throw them back in. Then I got a 7 out of 21 chance to get another one, and that's 0.1111. Sorry. Yes. Felt that way. 2 things about that is I've used this worksheet for like 12 years. So, but also dividing by 9 is easy. 2 9s is 0.222. 3 9s is 0.333. 4 9s is 0.4444. Now I'm doing the exact, I love to do this. Same exact question, but different situation. So I'm still, the independent is still going to be a 2 out of 21 chance, but then I let them leave. Right? Oh, thank you. What's probably now that I get a Republican after I let that person leave?
12 out of 20.
Yeah, still 12 Republicans in there waiting to get out, but now there's 20 people in there because I let one go. 12 out of 20. What's that going to be, boy? 0.05.
7.
What is it?
7 1.
7.1. And then now, this is the one time you got to be careful. The first guy's a Democrat. Person. Let them leave. Was probably get another Democrat. Well, I lost a person and I lost
A
Democrat. So what's the second fraction going to be? 6 out of 20. 32, that's 10%. Okay, I like it. It's really good. This isn't difficult. So I love it. You're either upset that it's difficult, or you're like, this is easy, let me go. I love it. I can see it in your eyeballs. All right. Number 3 is going to be a little weird. Not just because of the content, but how to do it. Part A hopefully was easy. How many spots do I put for Part A like we did in the last one? How many things am I picking?
4.
4. So I'm going to have 4 spots. Separated with times, because it's what's probably the first one thinks that chocolate milk comes from brown cows. And the next one doesn't, and the next one doesn't, and the next one does. There's hidden ands again. So I got 4. How big is my population?
Too big.
Very big. Too big, all right. Well, all right. You're thinking about the number of people that think that this is true, right? So are you thinking about? The population in this case is the number of Americans, which I actually agree with you. There's kind of a population problem, but anyway. So the first one thinks that chocolate milk comes from brown cows, and the last 3 do not. So what number do I put in that first spot?
0.07.
Yes. That first person, there's a 7% chance that they think this. So that's what I put for the first spot, 0.07. Flop. And what's the probability that this person does not think that?
0.93.
It's gotta be 0.93, it's gotta be the rest. If 7% do think that, 93% don't think that. Oh, jeez. So this would be 0.07. 0.93, 0.93, 0.93. Now real quick, little word I wanna say here. Isn't this the same as this mathematically? Did I have to write that really? No, I can just throw all that shit in the calculator, but isn't that the same thing?
Mhm.
And doesn't this make sense? Doesn't this mean that one person thinks crazy things and 3 people don't? The powers actually tell you how many people are doing that thing. That's going to come back in chapter 4. And then whatever the hell that is. Wait, give me a second. 8, 7. It's like I don't know, it's like right around 0.5. Is that right?
Point zero.
What is
I
it?
got 0.0563.
0.05? Oh, I didn't move the decimal. Shit. I definitely should. So what is it?
0.0563.
0.0563. I can live with that. Now, listen. This next one would suck so bad if there wasn't a shortcut. No, I really want you guys to understand. What does at least 1 mean?
Anything equal to or bigger than 1.
Yes, so I could have one person thinks that way. Right? And it could, we already did one where one person thinks that way. Is this the only way that one person could think that chocolate milk comes from brown cows? Couldn't it have been the second person instead?
Yeah.
Or the third person? Or the fourth person? Third? Sure, Jeff. Or 2 people. The first 2, the last 2, the middle 2, the first one and the last one. Or 3 people, the first 3, the last 3. Or 4. You'd have to do all those calculations, add them all up. Do you want to do that?
No.
I don't want to do that either. Shit. So, the way to do this instead is to remember, if the probability it was going to rain today is 1%, well, it's probably it's not going to rain.
99.
We all know this shit, right? Yes? Opposite probabilities, one is 1 minus the other one, yes?
Yeah.
What is the opposite of at least 1?
0.
Yes. If I said at least one person in here liked season 8 of Game of Thrones, how would you show me that I'm wrong? Exactly. If I thought at least one person in here liked season 8 of Game of Thrones, how would you show me that I'm wrong? You'd have to show me that
We don't.
nobody did, right? If I think at least one person did, how could I be wrong if nobody did? In that case, isn't me being wrong the opposite of what I'm saying? So the opposite of at least 1 is none, which kicks so much ass. Because if I said nobody thinks that way, what's going to be in each spot? If none of these 4 people think chocolate milk comes from brown cows,
93.
93, 93, 93, 93. All right, let's catch all this shit. I love you guys. You're at least attentive and looking at me. So, at least 1, the probability of, let me be all technical here. At least 1 is 1 minus the probability of none. So if I figure out the probability that nobody thinks that way, I can just do 1 minus that. So it'll be 1 minus, can we just do this? I'm not going to put all, it'd be 0.93 to the, because I got 4 of them, right?
Fourth.
To the 4th. 7, 6, it's going to be 0.345.
Wait, why is it 0.93? So if you're saying none or,
What's the probability that at least one of them thinks chocolate milk comes from brown cows is 1 minus the opposite of that, which is nobody thinks chocolate milk comes from brown cows.
so then if it's nobody, why would it be 0.93?
Because, what did we just say? Nobody thinks chocolate milk comes from brown cows. So this guy doesn't think it, this guy doesn't think it. What's the probability somebody does not believe that? 93%, yes? Because there's a 7% chance they do believe that.
Oh.
But we have figured out, if I just do this question, which is nobody believes that shit, I could do 1 minus that and actually answer the question. So it's sort of like you're answering the opposite of the question first, and then you do 1 minus that, bam, you got the question answered. Yeah. All right, and then what is that?
It's 0.7481.
7481.
That's what I got.
Well, that's what 93.
To the 4th power is? Oh, okay, so 1 minus that.
It's, it's 2519. Okay.
I got 0.2519.
2519, that sounds about right. Are you guys okay out there?
Yeah.
So, if you want to see in your calculator, you could just do this. 1 minus 0.932 to the 4th, 0.2519.
And this works for any time that it says at least one?
Yes, as long as I'm having whole number possible outcomes, right? You can only have a whole number of people, thankfully. Right, so that means that it's 0 and up. So the opposite of at least 1 will always be none. Not cute so much as. When does that work? Always. If the probability of the opposite, listen, if they ask me a question, and the probability of the opposite of the question asked is easier, I'm gonna do that. And then 1 minus and answer their stupid question, yeah? That's when does it work? All the damn time. Anytime the opposite probability is easier, shit, yes, I'm gonna do the easier shit. Could you do the harder shit? Of course you can. I don't know why you would want to. And then the last question, it's gonna be weird. This is really weird. Let's pick a symbol for, where'd it go? This number. Let's pick a symbol, let's not use A or B or whatever. What makes sense? The probability of what? Like pick a letter to represent 7%
B.
of Americans think that chocolate milk comes from brown cows.
B for brown cow.
Also realize that later we're gonna have Brussels sprouts.
Okay.
So let's use
C.
C. All right. So the probability, and that's a double duty thing, right? Chocolate milk comes from brown cows. Okay, C is beautiful. Is 0.07. That I know from the beginning. What new thing do I tell you? 4% think that chocolate milk comes from brown cows and that Brussels sprouts are the best vegetables. So basically, 4% of Americans are completely insane. If you like Brussels sprouts, you can have all of them.
I'll take them.
Although I have had some at Bobo Kitchen, the fried Brussels sprouts with some bacon. I mean, yeah, bacon, anything, I'll have it. So 4% think that chocolate milk comes from brown cows and Brussels sprouts are the best vegetables. So the probability that they think chocolate milk comes from brown cows and Brussels sprouts are the shit is 0.04. So what I'm doing for myself is I'm collecting the information in a form that will live in formulas. Because I don't have anything to count here, right? Now, can you give me the symbol for what they asked me?
What do you mean by that?
Can you put the question into symbols like this? What is the question?
P, B and C divided by.
Oh, I see. No, not the formula. Just
Okay.
the probability that American likes Brussels sprouts, that's B, yes?
Okay.
You've chosen the letter B to mean liking Brussels sprouts. Yes?
Yeah.
Given, okay, B, given they think that chocolate is C. So B given C. I love you guys. Oh, you guys are like, we should have left like 10 minutes ago, Chad. Please just let me. No, too bad. I'm gonna finish this damn thing. What the hell is that formula? The letters don't mean anything, yes? They're just like X and Y. You eventually learned they didn't have to be X and Y. They could have been C and D, whatever the hell I want to, yes?
Yep.
So, we know the probability of A given B, so we know the probability of B given C. And you started doing it, but can somebody else tell me what that's going to be? What's the probability of A given B? It's probability of A and B divided by the probability of B. So the given is always on the bottom. So what's this? Isn't this the probability of B and C divided by the probability of C. Do I know those things?
Yeah.
Yeah, I know C and B, B and C, that's 0.04, divided by 0.07, which is the 5714 again. If I'm thinking right. I don't know. if I'm thinking
Yeah,
right.
that's right.
sounds
That's
right.
0.04 divided by 0.07, 5714. Holy shit. Holy shit. So what's gonna happen is I'm gonna have an answer key for the back, but you guys can try it. Obviously, your main priority is doing the homework. So this is sort of like a practice test, right, on the other side? So I'll have an answer key for that next time. When is the double quiz?
Tuesday.
Next Thursday.
A week from today. Which I think is my birthday. What is today?
The
14th? Yeah. So a week from today is my birthday, so that's how I'm gonna celebrate. I'm gonna make you guys give me more to grade.
That's very nice of you.
Oh, so nice. I'm so nice to you and to me. It's crazy.